Let's get started. Here's how we're gonna do slope fields. It's not hard at all. It's actually very easy. Usually the free response question that deals with slope fields is one of the highest points, usually. So we hope that we have a slope field question as a free response. So here we go. Here, how do you do this? Usually, guys, these points are called lattice points because they're integers. And all you're doing is you're going to draw little slope segments. So look at number 1. It says the dy dx is x plus 1. Remember, dy dx is a slope. So I'm going to start on the x-axis. You know what? No, I'm going to start at x equals negative 1. So at x equals negative 1. Oh, sorry. Sorry, guys. Sorry, Aleman. At x equals negative 1, all the slopes there are going to be 0. Why? Because negative 1 plus 1 is 0. Does that make sense? So look, negative 1, that's negative 1 plus 1, which is 0. Negative 1, negative 1 plus 1, 0. I'm talking about the x value, negative 1, negative 1 plus 1. It's affected only by the x value, so all those slopes there are 0. Does that make sense to everyone of what I just said there? Okay, next, and I'm literally just going lattice point to lattice point. I'm literally just going every point, guys. So I'm at the origin. The x value is 0 at the origin. 0 plus 1 is 1. It doesn't have to be perfect, but here's my slope of 1. And use the other, when you draw your segments, use these points to help you out. See, that's the slope of 1 there. So don't do that, of course. Just there it is, just my little segment there. Slope of 1, use the little points to help you out. Slope of 1. At the AP exam, at the reading, they're not going to be looking like, oh, is it a perfect one? No, they're not going to do that. They're just going to check to see more or less if it's a positive slope of 1. And there it is, guys. At x equals 1. Well, at x equals 1, this is 1 plus 1, so 2. So let's see, a slope of 2. 1, 2, 1. So slope of 2, there it is. Doesn't have to be perfect. Just make it more steeper than the previous one. See? Oh, it did it again? Or it never picked it up? I wonder why it's doing that. Well, you shouldn't have to get on Zoom if you're here. Unless it's for like record purposes. Come on, guys, we're having technical difficulties. There we go. Sorry about that, miss. All right. At x equals, let's see, 1, 2. This is 2 now. 2 plus 1 is 3. So it's going to be something like, bam. Okay. 3 plus 1 is 4. So let me see if I can get to the 4th slope here. So there it is, guys. Now I'm going to go to negative 2. Negative 1, negative 2. Negative 2 plus 1 is negative 1. What's up, Tiff? I put a paper right there for you. And don't worry, you haven't missed much. We just started, and we just started this one here. So at negative 2 plus 1 is negative 1. So here's negative 1. And there it is, little slope segments of negative 1. Go to the next one. That's negative 3. Negative 3 plus 1 is negative 2. So steeper, but in the negative direction. And there it is, guys. And there it is. There's your first slope field. I hope that you can tell. And what's the point of a slope field, guys? If I were to find the original equation, your y would equal, let's see, x squared over 2 plus x plus c. And those are all parabolas. So look, how does the parabola look on that one? It could be that one. If I'm at a different location, if I'm over here, it could be this one. See, if I'm over here on the green one, if I'm over here, it's this one. You just follow the slope fields. Where have you seen slope fields before? The weatherchannel.com, when they're showing about the winds, you know, like the direction of the winds, this is what they do. So all those weather people, weatherman people, weather ladies, they've all taken calculus because of this right here. Actually, with the weather people have taken a lot of math courses actually. But yeah, next time, you know what? Next time I'm going to watch the news tomorrow or tonight, and I'm going to send you a picture of this. All right. Let's do the second one here, guys. Number 2. Notice that the slope is only affected by the y value. So on the x-axis, the y value is 0. So that means all of these are zeros. 0, 0, 0, 0, 0, 0, 0. And you're just drawing little segments on every lattice point. The next one up, that's a y value of 1. 2 times 1 is 2. So just make a slope of 2. Doesn't have to be perfect, guys. Doesn't have to be perfect. Slope of 2, 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 slope of 2. The next one on top of that, 2 times 2 is 4. Just make it a lot steeper than the one on the bottom. Positive slope. There it is. At y equals -1, 2 times -1 is -2. So a slope of -2. At y equals -2, a slope, 2 times -2 is -4. So a slope of -4. And you're done. That's it, guys. Simple. How do we feel so far? Do we feel okay? All right. Number 3. Oh no, Chavez, it's going to get really complicated. I don't know how to do these. Relax, guys. Do them one point at a time. If you want to just do it one axis at a time, go ahead. So I guess let's start at the origin. At the origin, the point is 0, 0. So I have a slope of 0. 0 plus 0 is 0. And if I go up the y-axis, so the x remains the same. So 0 plus 1 is 1, so slope of 1. So 1. 0 plus 2 is 2, so slope of 2. So make it steeper, but positive. And there it is. Now I'm going down the y-axis. 0 plus a -1, that's -1. Use these points to help you out. Chavez, what do you mean? That's a linear line with a slope of -1. So use that to help you out. So there it is. That's my slope of -1 there. -2. There it is. See? Do the same thing with the x-axis. So let's see. On the x-axis, 0.10, that's a slope of 1. Slope of 1. At 0.20, that's a slope of 2. And then slope of 3. At -10, slope of -1. At -20, slope of -2. And then -3. It does not have to be perfect, guys. The readers are not going to be taking out rulers to check that your slope really is -3. Just make sure that it looks steeper than the last one. All right, now how do we do the other ones? Here's what I would do. Look for patterns. You know that this x plus y, you know that x plus y is going to be 0 if the magnitudes of your x and y coordinate are opposite. Does that make sense? I'll say it again. You know that when you add them up, it's going to be 0 if the magnitudes are the same, but the values are opposite. So what does that mean? At 1, -1, that's a slope of 0. At 2, -2, that's a slope of 0. 2, -2. And you're going to notice a linear line, y equals -x, has to be a slope of 0 all the time. So -1, 1, slope of 0. -2, 2, slope of 0. So there it is. To the right of that line, by the way, this is not the correct line, guys, but to the right of what you see in green there, that linear line y equals -x, all the slopes should be positive. And to the left of all the slopes to the line of the green line there, all the slopes should be negative because of the y of the dy dx equals x plus y. I'm erasing the green lines because that's not, I don't want anyone to confuse that for the equation. All right, here we go. What was that? So now let's just do point at a time. Let's see, -1, 2. I'm looking at the lattice point, -1, 2. That's a slope of 1. Boom. Now I'm looking at y equals 1, 2, y equals 2, and I'm just going across it. So I'm going to start first with the one right to the left of that one. I'm starting with that one right there where the arrow's at. That is point -32, so a slope of -1. Boom. Matter of fact, I hope that you can see it. This is a slope of -1, and look at all that. You have a nice linear line right through every time that the magnitudes are different by 1, but in the negative direction. All right, let's keep going. Let's see. I'm at 1, 1. Well, that's a 2, so slope of 2. And then at 1, 2, a slope of 3. Boom. I'm done with that. Now I'm at 2, 1, a slope of 3, and a slope of 4, so even more steep. Now I'm at 1, 2, 3. I'm at 3, 1, a slope of 4, and a slope of 5. It's already looking almost like tangent, but it's not. I got all of quadrant 1 done. Let me work on quadrant 4. I'm looking at point 2, -1. So 2, -1 is a slope of 1. So here's my slope of 1. Now I'm looking at point 3, -1. That's a slope of 2. So let me see, slope of 2. And then 3, -2, slope of 1. Boom. Now I just have one little point in quadrant 2. Let's see, I'm looking at point 1, 2, 3, -3, 1. So that's going to be a slope of -2. So let's see, -2, boom. 1, 2, boom. Yeah, there it is. And now let's finally fill in quadrant 3 here. Let's see, -1, -1, that's -2. And then -1, -2, that's -3. So make it steeper, but negative. All right, now I'm looking at -2, -1, that's a -3. And then -4 for the one below that one. And then -4 for the -3, -1. And then -5. Practically vertical, not really. I'm exaggerating it, but there it is. Well, that was tough, guys. But see, we can do it. Don't worry, on the AP exam, they're not going to make you to do all these little points. We're just doing that right now because we got to get more experience. All right, let's do number 4 together. This one is only affected by the x value. Simple. So the y-axis needs to have slopes of 0. 0, 0, 0, 0, 0. The x equals 1, slopes of 2. 2, 2, 2, 2, 2. The x equals 2, slopes of 4. 4, 4, 4, 4, 4, and then slopes of 6. Make it a little steeper than the other one. Do the same thing on the left-hand side. -1, so slopes of -2, -2, -2, -2, -2, -2, -4, and then -6. Hopefully you can see that I have a whole bunch of family of parabolas. If they were to tell you, oh, okay, draw a sketch, so here's a point, and sketch a graph going through that point. Oh, okay, it looks something like, and you just follow the slope field. Does that make sense? The slope field tells you what direction to go. And you see it all the time with weather maps. So as soon as, I'm excited to watch the news tonight, so I can send that picture to you guys. All right. You know what? I need to take a look at that because this person that just texted me doesn't usually text me back to back time or back to back. So hold on, guys. I hope it's not an emergency. No emergency. See, she just sent a funny TikTok. I haven't seen it yet, but I'll look at it right now. All right, number 5, y-1. The thing, I love these guys. I love it when it's just one variable because I can find where it equals 0 right off the bat. Where does it equal 0? Whenever the y value is 1. Where is the y value 1? At the y equals 1 line. 0, 0, 0, 0, 0, 0, 0. All slopes above that line are going to be positive. all slopes below that line is going to be negative. That's simple, guys. So at the y equals 2, 2 minus 1 is 1. Make a slope of 1. 1, 1, 1, 1. Boom, there it is, done. All slopes on the x-axis, the y value is 0. 0 minus 1 is negative 1. Make a slope of negative 1. Negative 1, use this guy to help you out. See, that would have been a linear line of slope of negative 1. So just aim it towards that. Negative 1, negative 1, negative 1, negative 1. The next one is going to be a slope of negative 2 because negative 1 minus 1 is negative 2. So negative 2, make it steeper. Doesn't have to be perfect. Negative 2, negative 2, negative 2. And then finally, negative 3. There it is. If they were to tell you, again, they're not, but if they were to tell you, sketch a graph that goes through this point in blue, it would probably look something like, do I cross the line y equals 1 if I'm above it? What do you guys think? No, you don't. Because as you get closer to that line, to the y equals 1, it tells me that I just continue going to the left. You just follow the slope field. So depending on the equation, depending on what they give us, if they give you a point above that line y equals 1, it's going to look like that. If they give you a point below that line, it's going to look like this. Man, isn't math beautiful? See, this is where your two general equations come in. Like it depends where you're at. Okay, let's continue, guys. All right. Here's where delta math is flawed. And I said it, I already emailed him. I emailed him last year and he replied with, yes, he understood. And he didn't fix it because I just checked today and he still didn't fix it. I know why he's not fixing it. I think I know why he's not fixing it. So a warning, everywhere the slope is undefined, if slope is undefined, do not draw a tangent, do not draw slope fields. If slope is undefined, do not insert slope. Do not insert slope. Sometimes we have curves that do have tangent lines, that are undefined, like a circle. If you have a circle, you have tangent lines undefined here and here. And you can draw slope fields for that. But sometimes you just have something like y equals 1 over x. And when you take the derivative of that, you get negative 1 over x squared. And this is the same thing as saying dy dx, right? And look, you don't have, so some students, they go to x equals 0 and they write tangent lines as slopes. But you don't have a tangent line at x equals 0. You have a vertical asymptote. Does that make sense, guys? So ETS, College Board, had literally, they told us this because I was there, I was part of it. They do not want you to be drawing any slope fields if it's undefined. Cool or not cool? Delta Math has you drawing slope fields, even though they're undefined. For now, I'll allow it. I'm going to email him again, though, soon. I know why he's doing it. He's not wrong. He's not wrong because there are some curves. There's some curves. What if you have like y equals x to the 1/3? Do you guys know how that curve looks like? I hope, okay. It's the inverse of y equals x cubed, guys. So that curve looks like this. So yeah, that one does have a tangent right there. A vertical tangent, an undefined tangent. So if you were to draw a slope field for y equals x to the 1/3 plus c, yeah, there would be a whole bunch of tangent slopes right on the x-axis, a whole bunch of them, because there really are tangents there. But that's an exception. Like, you know what I mean? Does that make sense? That's an exception, guys, because right, the dy dx is like negative, what is it? No, 1/3 over x to the 2/3. Anyways, all right, so you know what? All that I just said, if your slope is undefined, do not insert slopes. Just write that. If the slope is undefined, do not insert slope. That's simple. Cool or not cool? Okay. All right, guys. Quick note, everything in quadrant 1 is going to have negative slopes. Everything in quadrant 2 is going to have positive slopes. I know, everything's going crazy today. That one's probably Mark Townsend because it's an Austin number. So he probably wants to talk or something. Okay, you guys ready? All right, here we go. I am starting at 1, 1. At the point 1, 1, that's going to be a negative 1. Cool. Let's see, where now that I did 1, 1, should I continue with quadrant 1? Probably. Let's go to y value of 0, x value of 1. So this is a slope of 0 there. So slope 0 is right here because all of those, be careful with the origin, do not put a slope field on the origin. So now let's go to 1, 2. So that's going to be a slope of negative 2. So now I'm at 2, 1. So that's going to be a slope of half. So it's going to look like that. Negative half, sorry. I've been saying positive numbers, but drawing negative slopes. Everything in quadrant 1 is negative. And now I'm at 3, 1. So that's going to be a slope of 1/3. So even flatter than before. And there it is. I'm done with that line. Now I'm going to go to the slope. I'm going to go to 2, 2. 2, 2 is negative 1. And now I'm going to go to 3, 2. That's going to be a negative, what's that? Negative 3 over 2, negative 1.5. Nope, negative 0.66. You guys got to correct me, guys. I make mistakes all the time. I didn't do that one on purpose. And there it is. I got my first quadrant. They're all going to look more or less exactly the same, but in quadrant 2, they're going to be all positive slopes. So I'm at negative 1, 1, positive slope. If you want to make life easy, negative 2, 2, positive slope of 1. So there you got those two. Negative 1, 2. That's going to be a slope of 2. So there it is. We got that line there. So now let's go to negative 2, 1. That's going to be a slope of half. Negative 3, 1. That's going to be a slope of 1/3. Negative 3, 2. That's going to be a slope of 2/3. Wait, hold on. Did I say that right? Yeah, 2/3. There it is. Let's go to the quadrant 3. The first one I would do would be negative 1, negative 1. That's everything in quadrant 3 is going to be a negative slope. Negative 1 is a negative 1. Negative 2 is a negative 1. So there it is. All right, so now I'm going to go to negative 1, negative 2. So that's going to be a slope of negative 2. So now I'm at negative 2, negative 1. That's going to be a slope of half, negative half. And now I'm at negative 3, negative 1. That's going to be a slope of 1/3, negative 1/3. Negative 3, negative 2. That's going to be a slope of negative 2/3. There it is, guys. Finally, the last one here, quadrant 4. 1, negative 1. All these slopes are going to be positive. Positive 1. And 2, negative 2, positive 1. Now I'm at 1, negative 2. That's going to be a slope of positive 2. And now 2, negative 1, that's going to be a slope of half. More a little flat. And then 3, negative 1, it's going to be a slope of 1/3. And then 3, negative 2, that's going to be a slope of 2/3. Sorry, guys. And there it is. Oof, that was tough, but look, we got them all, guys. Are you guys proud? All right. So now we got questions. Matching. It says match the slope fields with the differential equation. So I always like to start with the easiest ones, guys. So let's just start with the easy ones. Let's look at number. Well, you know what? Let's just start at number 7. Number 7, dy dx equals sine x. Look at the graphs A, B, C, and D. Which one looks like a sine x? Which one looks like it just keeps going up and down, up and down, up and down, up and down? A, B, C, or D? Yeah, C, and then Charlie. Look, guys, it looks like if you follow, I'm trying to follow, but it looks like it's going up and down over and over again, guys. All right, number 8, x minus y. So the way I would do this one real quick, if I set that equal to 0, I know that I have 0 slopes as long as x equals y or y equals x. So that's what I'm looking for. I'm looking for 0 slopes at y equals x. And look at this. Boom, 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 boom. There it is. This one is D. Do you see how I found it really quick? Number 9. Number 9 is only affected by y. So look for, remember my little hint, I'm going to equal it to 0, and that only happens if y equals 2. So I'm going to look for a graph where at y equals 2, I have slopes of 0. And check it out. Boom, 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 boom. A. Everything above A is negative slopes. Yep. Everything below A is positive slopes. Yep, it works. And then for number 10, it's just affected by the x-axis. So if I move to the right, positive slopes. So if I move to the left, negative slopes. So number 10 has to be B. Do you see how we did it, guys? Okay. Here we go. Match the slope fields with their differential equation. Let's see if we can do it again, guys. Number 11, 0.5x minus 1. It's only affected by x. So look for a graph that is only affected by x. It looks like this one. Chavez, what do you mean it's only affected by x? I like to look left to right. Look left to right, it's only being affected by x. See? Doesn't matter where. Maybe some of you saw the letter B and you saw that there were parabolas. Yeah, if you were to do the antiderivative of that, that would be parabolas. And I see a whole bunch of parabolas, depending on where you're at. See, guys? Easy. Number 12, it's only affected by y. So that means go up to down and see that it's only affected by the y value. And you can see right off the bat, it's only going to be, there it is, letter C. Everything above the y equals 0 is positive. Everything below the y equals 0 is negative. Number 14. I guess let's do number 13. Number 13, there's a negative here. So that means everything in quadrant 1 has to be a negative slope. Everything in quadrant 1 and 3 must have negative slopes. And then I'm going to put here, that's first bullet, second bullet. Everything in quadrant 2 and 4 must have positive slopes. So number 13 has to be D because of that. And I don't know if you can tell, but those are circles. And a long time ago, I don't know if you remember, but when we did the x squared plus y squared equals some constant, and we found dy dx, the dy dx of that circle was negative x over y, if you remember. I don't know if you remember. It's okay if you don't. Number 14, x plus y, I always like to set that equal to 0, so I know exactly what I'm looking for. I'm looking for horizontal tangents along the line y equals negative x. Bam. Found them real quick. I mean, even though we got the other ones already, so we already knew them. But yeah. And they're kind of fun, guys. They kind of become fun the more you do, the more that you do of these. Are we understanding this, guys? Because I can't tell right now if we're getting it or not. Okay. All right. This is from the 2008 AP exam. Tiff, we're feeling pretty good? We got it all stone cold? From the 2008 AP exam, question 15. It asks, the slope field for a certain differential equation is shown above. Which of the following could be the specific solution to the differential equation? Okay, you're looking at it. Does it look like I have parabolas? I'm not saying that's the answer. Does it look like I have parabolas embedded in there? Like, do I see parabolas in there? No. A's out. Do you know how e to the x looks like? So that might be an issue. Hopefully by now we know that e to the x looks like this. That graph does not look like it would fit in there. That one's out. E to the negative x. E to the negative x looks like this. This graph does not look like it fits in there as well. That one's out. Cosine x. No, it's not moving up and down. Look, it doesn't fit. Out. ln x is the answer. They didn't show the bottom stuff, but look. That could be one, or this could be one, or it fits. It fits. It's logarithmic. Do you see that, guys? Okay, don't worry. We're going to do a fun question right now in a little bit. Number 16. These are coming from from an actual AP exam, the 2008 exam. The slope field for a certain differential equation is shown above. Which of the following could be a specific solution to the differential equation? Okay, well, does it look like it's going up and down? Nope, that one's out. So these two are out. Those are the worst ones. Actually, the next one's also pretty bad. Does it look like I have parabolas in there? Does everyone know how a cubic function looks like? Does that look like it could fit that? Yeah, there it is. And we just talked about that one. It can't be that one because it has to look like this for ln x. So there it is, guys. All right, I will eventually in time tell you guys to do this one on your own. But today, because it's the first time that we've been talking about slope fields, we're going to do this one together. And in the future, I'll set you guys loose. If you want to try to see how much you can get really quick, it says, consider the differential equation dy dx equals y squared over x minus 1. On the axis provided, this is coming from the real AP exam. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. All right, guys, just these 6 points. Do not write any more. So let's just go one at a time. So at 0, 0. 0 divided by negative 1 is 0, so that's a slope of 0. See? At the 2, 0, that's a slope of 0. Does everyone know how I got those two answers? All right, so now for the next one. This point is 0, 1. If you want to go to the side, dy dx at 0, 1, you can do that. And you can say, okay, 1 squared over 0 minus 1. So 1 over negative 1, negative 1. So that's the slope of negative 1. So there it is, negative 1. At 0, 2. Let's see, 2 squared over 0 minus 1. So 4 over negative 1, so negative 4. Negative 4, they're not going to check to see that it's perfect. Just make it steeper in the negative direction. Three squared is 9. 9 divided by negative 1 is negative 9. Make it real steep. Oh, and I just said, man, I need to take my own advice. There it is. Now let's go to the next one, 2, 1. So if I go to 2, 1, let's see, the 1 squared is going to be 1. 2 minus 1 is 1. 1 divided by 1 is 1. Slope of 1. There it is. Bam. If I go to 2, 2, 2 squared is 4. 2 minus 1 is 1. 4 divided by 1 is 4. So there's my slope. There it is, guys. Done. Doesn't have to be perfect. Done. Letter B. Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph at x equals 2. Use your equation to approximate f of 2.1. Okay, I'm going to slow down. A lot of you that did the bonus, or it wasn't a bonus, a lot of you that did the spring break work, let me know on the feedback. Well, not a lot of you, because only 6 attempted on this one, but 2 of you told me that you found the equation, the general equation, and then did it from there. That's not what they're asking for, guys. Look what they're asking for. They're asking for a what? A tangent line. Hey, no yawning. That's the merit. They're asking for a tangent line, guys. So what do you need for a tangent line? You need 2 things. A slope and a point. Guys, you have a slope. Here's my point. And you have a slope. What's my slope at 2, 3? The slope at 2, 3 is 4. You can just write it over here if you want. dy dx at 2, 3 equals, it's not 4, sorry. At 2, 3, oh, okay, it's a point way over here. They don't give me that. It's 9, I think. So dy dx, so you're going to have to show that because it's not a point that they give you. So 3 squared is 9 over 2 minus 1. So my slope is 9. So here we go. Y minus 3 equals 9, x minus 2. There's your tangent line. You get a point for that. Now I'm going to figure out what f of 2.1 is. So I'm going to write f of 2.1 is approximately 9 times 2.1 minus 2 plus 3. If you want, you can leave it alone right there if you're scared. But are you scared? Oh, I was hoping that you're going to say no. We're not scared, right, Alaman? We're not scared, guys. So go for it. 9 times 2.1 minus 2, that's just 0.1 plus 3. You can do that you can do that, guys. 9 times 0.1 is what? Oh, man. What's 9 times 1? 9. So what do you think 9 times 0.1 is? 0.9. 0.9 plus 3? 9. 9.3. Oh, yeah, I got it wrong. You see, so maybe we should be scared. 3.9. Man, I'm so dummy. I'm such a dummy. We should be scared. I'm rusty. I haven't done Cal. Well, actually, no, I've been doing Cal throughout spring break. And there it is. Do they want anything else? No, I think that's it. All right, last one, letter C. Find a particular solution, y equals f of x with a given differential equation with the initial condition f of 2 equals 3. Okay, I love when they ask these questions because there are so many free points. First thing you do, write this guy. Look at all the free points they give you. Well, we haven't looked at the rubric yet, but y squared over x minus 1. We'll look at the rubric right now. All right, here are some free points, guys. You separate the variables, they give you a point, just to separate them. The y's with the y's, the x's with the x's. So here we go. I'm gonna write dy over y squared equals x minus 1 dx. You do that, I don't know, I'm taking a guess that it's a point. It might be 2 points. That's a point right there, right off the bat. Can you at least do that? Okay, next. What do I do next after I do that? It starts with the letter I. Oh, man. Integral, guys. I integrate. I know it's early, where maybe we're not used to the daylight savings time, guys. But come on, guys, we have an exam not too long from now. Dy over y squared, we're going to integrate. So here we go. Hopefully you don't need much help with that. That is going to be a negative 1 over y equals x squared over 2 minus x plus c. In case you don't know what I did, this is the same thing as y to the negative 2 dy. So add 1, divide by that power. Just to get to there, I'm taking a guess, That's one, sometimes 2 points. 1 point for the one on the left, 1 point for the one on the right. And with the C, it's another point. With the plus C, it's another point. I like to solve. Oh man, I already got it wrong. Do you guys see the error? How come you guys didn't tell me? That's wrong. That's wrong. That's wrong. I would have gotten +1 here. No, I would not. I would have gotten that wrong, but I would have gotten +1 because they can't give me both points. Does anyone see what I did wrong, guys? It's on this step right here. What did I do wrong? Look carefully. Look at the x minus 1. Look at where it's located here. It's supposed to be 1 over x minus 1. You don't have to erase the whole thing. You don't have to erase the whole thing. So this was correct. Integral 1 over y squared dy. This was supposed to be integral 1 over x minus 1. Yeah, see, I make mistakes too, guys. I wasn't able to fall asleep last night because I was so excited to be back. No, I'm not even kidding. But yeah. All right, so here we go. Now we're going to do it right. -1 over y, I think that's correct, equals, what's the antiderivative of that guy? What's antiderivative of 1 over x? ln x. So what do you think the antiderivative of 1 over x minus 1 is? And I got to put what? There's no limit, so I got to put absolute value. You have to put absolute value because I have no limits right now. No limits. Put ABS. I'll check the rubric right now. Okay. Now that I notice, you see how I have x equals 2, 3 here? Since I have this, and I know that if I'm talking about x equals 2, that means that x is greater than 1, right? Okay, maybe I'm going to confuse you. I don't want to confuse you. What I'm trying to say is this. ln, absolute value of x minus 1, is the same thing as ln x minus 1 with parentheses because x is greater than 1. Put that somewhere. Put that somewhere. Does that make sense to everyone of what I wrote right here? I will put that somewhere, guys. And then once you put that statement, I would probably put that statement like right here. And then I can just write -1 over y equals ln, and I can just write x minus 1 plus c. And now I can just use my point, f(2,3). So let's see, semicolon, -1/3 equals ln 2 minus 1 plus c, semicolon. Hopefully you know that ln of 1 is 0. You got to know a little bit of algebra, guys. Since I know that c is -1/3, oh man, I should have made more space. I'm going to come back to here. Where do I have space? I have space up here. I'm going to go to the top, to the very top, because I got space up here, guys. So here we go. I have -1 over y equals ln of x minus 1 minus, was it -1/3? Yeah. That's a c value, right? From right here. That's my general equation, and that's the c value that I found. You're almost done, guys. You just got to get it in terms of y equals. So I do not know if they have this answer like this. I'm going to do a cop-out. I'm thinking that they do because they probably have the answer that most kids probably did. They're stuck for time. So I'm thinking that most kids probably did this. That negative, move it to the other side, and then just flip everything. So I'm going to write y equals negative on the outside and write 1 over ln x minus 1 minus 1/3. You can bring the negative on the inside too and write 1/3 minus ln, but that's probably the answer that they're going to have, or at least one of them. How do we feel? All right, should we go look at the rubric?